Limits to infinity. We've already seen limits as x gets closer and closer to value, but I don't think we discussed it when x is taken to infinity. Now the simplest question that you can think of here is, what's the limit of 1 over x as x goes to infinity? Well, x going to infinity means that your values are ever increasing, like 1,000, 10,000, 1 million, billion, trillion, and so on and so on. So what happens to this value when you divide, when you plug in a million, for example? Well, that's going to be a very small value, right? So that's going to be like 0.5 zeros and then 1. So you can see that as x gets bigger and bigger and bigger, this should give you 0. Slightly more involved example would be when you have top and bottom as polynomials. X going to infinity, and say 3x squared minus 5x plus 7 over 2x squared plus x minus 1. Now, in this case, the rule that you learned in pre-calculus, well, you've seen something similar to this in pre-calculus when you were taught how to find the horizontal asymptote, right? The rule that you learned in pre-calculus is to divide by the highest power of the denominator, right? So if you have 3x squared minus 5x plus 7, 2x squared plus x minus 1, x squared is the highest power of the denominator, right? So this is x squared. So you're going to divide top and bottom by x squared. And remember, that's possible because you're working with a fraction. In a fraction, you can divide top and bottom by any number or anything, as long as you're dividing the top and bottom by the same thing. And then, you can break up these fractions as like this over this, this over this, this over this, here, this over this, this over this, this over this. That's possible because it's a fraction. You can have a common denominator and you can break up fractions that way. So you have 3x squared divided by x squared, which is just 3. X divided by x squared, well, one of the x's will cancel and you get x. And then 7 divided by x squared over 2x squared divided by x squared is 2. X over x squared would be 1 over x. And then minus 1 over x squared would be just 1 over x squared. You're sending x to infinity. And now it's clear because you're dividing a finite quantity by something that's very, very, very large. It's like this. If you have 5 pizza and you have like 10 friends at a party, then everybody eats half a pizza. But what if you have 5 pizza and entire school has to share it? Then you get very little, right? So when x is really, really large, this just becomes 0. Same fate with all the other ones. So you end up with just 3 over 2. That's how you handle these kind of limits. Now, let me show you some other similar questions. So here is what happens if the bottom is of higher degree. Well, in this case, again, the same principle works. You divide top and bottom by x to the 5th power. So you have 3x squared divided by x to the 5th. X divided by x to the 5th. 3x to the 5th divided by x to the 5th plus 1 over x to the 5th. And this just cancels, but that's limit x going to infinity of 3 over x cubed, because x squared, this x to the 5th is x squared times x cubed, so x squared cancel and you're left with x cubed. X to the 5th is x times x to the 4th, so after canceling the x, you end up with x to the 4th, 3, and then plus x to the 5th. And you can see that all of these should go to 0, so you end up with 0 over 3, which is 0. Okay? So another thing that we learned is that if the denominator has a higher power, then the limit would just simply be 0. What if it's the other way? What if you have x going to infinity, and you have like 4x cubed minus 4x plus 1, whereas in the bottom you have 3x squared plus 2x plus 5. Now, for this example, again, if you divide top and bottom by x squared, let me skip some steps. At some point, you're going to be pretty used to dividing by these. So x cubed divided by x squared would be just x. X divided by x squared would be 4 over x. 1 divided by x squared would be 1 over x squared. And 3x squared divided by x squared would be 3. 2x divided by x squared would be x. And finally 5 over x squared. Now in this case, these are zeros, but look, you have 4x over 3. So what happens is that when you plug in infinity, you get 4 times infinity, and you're dividing by this finite quantity, and therefore it's going to be infinity. Now in applied calculus, you may see some examples where you have limit with exponentials. Well, one thing that you have to know is that exponentials are faster than any other polynomial. So even if you have like x to the 100 power, when you have e to some positive power, this is going to be much bigger than this. Okay? In the beginning, when you plug in something like 10 or 100, you might see that the top is still bigger, but once you start plugging in something large, then this outpaces the top. So exponential growth, if something grows exponentially, that is actually a very terrible thing. It's very scary, so that's going to be 0. That's something to just know, okay? Now, we haven't done any limits going to negatives. So let me just quickly do one thing that goes to negative infinity so I can keep discussing exponential functions. So if you have x going to negative infinity of 2x squared plus 5 over 4x squared plus 2x. In this case, if you divide top and bottom by highest power of the denominator, which is x squared, then 2x squared divided by x squared would be 2. 5 divided by x squared would be 5 over x squared. 4x squared divided by x squared would be 4. 2x divided by x squared would be 2 over x. And then when you plug in infinity, again, you're dividing, even if it's negative, you're dividing by 2 divided by negative a million. That's very, very close to 0, despite the fact that it's slightly negative. It still goes to 0. So both of these will go to 0, and you still get 2 over 4. So in terms of polynomials, when you have polynomial over polynomial, in terms of these rational functions, sending x to negative infinity doesn't change that much. But when it comes to exponential functions, sending x to negative infinity might do something completely different. That's because if you look at the graph of e to the x, as you send x to negative infinity, so as your x gets further and further to the left, it just gets closer and closer to the x-axis without touching it. So what happens is that this is equal to 0. Now, in order to see that more clearly, here's how you can argue for it. You have e to the x, when you plug in negative infinity, here's e to the negative infinity, and that is going to be 1 over e to the infinity, because negative powers are always fractions, right? Negative powers, you can take the negative away by making it as a reciprocal. And e to any power, e to infinite power means it's a very, very big value, right? So it's 1 divided by infinity, which is 0. Okay. So that's how you can argue for it. Or you can just look at the graph and say, hey, this limit should be 0. Okay, and then finally, for exponential functions, another type of limits that I want you to know is when you have limit of x going to infinity, when you have mixes of exponential functions and polynomials. So let's say you have 3e to the 2x minus e to the x plus x divided by 5e to the 2x plus 5e to the x minus 1. Well, in this case, exponential functions are much, much bigger than any polynomial. So, okay, you know what? Let me just add x cubed just to make my point, okay? So even if you have x cubed, e to the 2x overpowers everything else. So when you want to divide by the highest power of the denominator, you should really divide by e to the 2x, which gives you limit x going to infinity of 3 times e to the 2x divided by e to the 2x is 1. E to the x divided by e to the 2x, oh no, what's that? Let me write it over here. E, for the lack of a space, I should really write somewhere here, but let me write it here. E to the x divided by e to the 2x. You know the rule that when you divide, the exponents subtract. So this is e to the x minus 2x. So that's same thing as e to the negative x. But just like how we did this, e to the negative x is same thing as 1 over e to the x. Okay. So using that, I can rewrite this e to the x divided by e to the 2x as 1 over e to the x, and then plus x over e to the x divided by 5 times 1, because e to the 2x divided by e to the 2x is 1, minus 5 over e to the x plus, actually minus 1 over e to the 2x, and then, oh, this should be e to the 2x, I forgot, okay. And then plus x cubed over e to the 2x. And all of these, when you have exponential functions, they overpower these polynomials, so all of these will become 0, and you're going to end up with 3 over 5 as the limit.